Alright, so in this video we go over section 5.3, dividing polynomials and synthetic division. So polynomial long division, we're going to do that first. In this case, well, we are going to divide these polynomials pretty much the same way we used to divide numbers. Alright, so what are we going to do first? Well, let's write this using the division notation, in which the numerator, which is the dividend, that's x squared plus 3x plus 2, and then divide that by, put down the divisor x plus 2 on the outside. Alright, so how are we going to divide these polynomials? Well, the way we start is by dividing the leading term of the dividend by the leading term of the divisor. That is, we divide x squared by x, and when we do that we get x. So we're going to put it on top of the x term right here. And then I'm going to multiply x times x. I'm going to multiply this x times all the terms that we have here. So x times x, x squared. X times 2, that's 2x. Do not put any signs here. Now the thing is, here when we do this operation, we are supposed to change the sign of whatever we get. For example, positive times a positive is positive, but we need to change that to the opposite, which is negative. Positive times a positive, it's another positive, but we need to change that to negative. What do we do that? Well, consider the numerical version of the division. That is, I don't know, let me give you an example. 17 divided by 3, for example. So 3 goes into 17 5 times. 5 times 3 is 15. But what did we do in order to complete the division? We subtracted this number, right? So 17 minus 15, that's a 2. What did we get? Positive times a positive is positive, but didn't we change the sign? Well, so that's why we do the same here. And once we're done, let's put the bar right here and cancel terms. So we cancel the terms like x squared minus x squared, and then combine these two. 3x minus 2x, that's 1x. And then the next step is to drop the next term, that is plus 2. Now what are we going to do? Well, because in this case the degree of this new polynomial, if we will, is the same as the one in the divisor, we need to continue the division. So we are going to divide the leading term of this guy by the leading term of the divisor. Now what are we going to get? X divided by x, that's 1. And then we're going to multiply 1 times all these two terms. So 1 times x, which is x, and 1 times 2, which is 2. But again, keep in mind that we need to change the sign of whatever we get. Positive times a positive is positive. We need to change this guy to negative. Positive times a positive is positive. We also need to change this guy to negative. And in this case, let's simplify the sum. Cancel, 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 cancel. And what we get is a 0 as a remainder. So our final answer is actually this quotient. In this case, simply x plus 1. All right. Let's do another example. Well, so for 2x cubed minus 6x plus 4, well, so we need to write this in the same way in using the division notation. All right, so let's write it down. 2x cubed minus 6x squared. However, notice something interesting here. The term that has x to the first power is missing. In this case, what we need to do is add a placeholder plus 0x and then minus 4. The reason why we add this placeholder is only to have a good organization of the terms once we perform the division, and then over x minus 4. So we're going to do the same. We are going to divide the leading term by the leading term. We divide both leading terms. So when we divide 2x cubed by x, we get 2x squared. And then when we need to multiply 2x squared times this x and negative 4. So 2x squared times x, that's 2x cubed. 2x squared times 4, so 2 times 4, that's 8x squared. Okay, but we need to change the signs of whatever we get. Positive times a positive is positive. We need to change that to negative. Positive times a negative, it's a negative. In this case, we need to change that to positive. Okay, let's simplify this. These guys go away, cancel, and negative 6x squared plus 8x squared, or 8x squared minus 6x squared, that's 2x squared. Now we need to drop the term, the next term, that's the 0x. Alright, so what are we going to do in this case? Well, so divide the leading term of this guy by the leading term of the divisor. So what we're going to do here is the following: 2x squared over x, that's 2x. And we're going to multiply 2x times x, that's going to give us 2x squared. 2x times negative 4, that, well, 2x times 4, that's 8x. But we need to change the signs of what we get. Okay, let me make this look like a 2. So positive times a positive is positive, need to change that to negative. Positive times a negative is negative, need to change that to the opposite, which is positive. So let's simplify, cancel, cancel. 0x plus 8x, that's 8x. Drop, the next step is to drop the next term, minus 4. And again, we are going to do the division of this leading guy right here over the leading guy from the divisor. So 8x divided by x, that's 8. 8 times x, that's 8x. 8 times 4, that's 32. Alright, but in this case, positive times a positive is positive. We need to change that to negative. Positive times a negative is negative. We need to change that to positive. So in this case, when we divide this, cancel, cancel, and 32 minus 4, that's 28. In this case, as opposed to the previous example, well, in the previous example, we got 0 as a remainder. And in this case, we got a remainder. So what did we do when we had remainders in numerical divisions? Well, in this case, the way we wrote it, it was in the form of quotient plus remainder over the divisor. In this case, the quotient, which is 5, plus the remainder, which is 2, over the divisor, which is 3. So 5 and 2/3. So we're going to do the same in this case. We're going to write this quotient. In this case, I'm going to box the quotient, which is 2x squared plus 2x plus 8, plus the remainder, which is 28, over the divisor, which is x minus 4. All right, and let's box all this. That's our final answer. All right, let's do one more. One more, okay, we're gonna change. We're gonna divide x cubed minus 8 over x minus 2. Well, so let me rewrite this in the form of a division, x cubed. But notice in this case, the square term and the x to the first power term are missing. So I'm gonna do the placeholder again, 0x squared plus 0x, then minus 8. Right? This way we have all the powers, and when we do the division, we can have everything organized nicely and neatly. And divide by x minus 2. So we're going to do the same. Let's divide the leading by the leading. Okay, so x cubed divided by x, that's going to give us x squared. I'm going to put it on top of the x squared. So again, if you notice the reason why we do this placeholding terms is to have everything organized by powers. See how all the x squares are here and all the x's are there. That way it's easy to follow, easy to read, easy to interpret. So x squared times x, that's x cubed. X squared times 2, that's 2x squared. We need to put the corresponding signs. Positive times a positive is positive. We need to change to the opposite, which is negative. Positive times a negative, it's negative. We need to change that to positive. So we're done multiplying these guys. Cancel, cancel. And 2x squared plus 0x, that's simply 2x squared. The next term is the next step is to drop this term. That's add the 0x, and we need to divide the leading by the leading. All right, so 2x squared divided by x, that's plus 2x. 2x times x, and that's 2x squared. 2x times 2, that's 4x. Now we need to change the signs. Positive times a positive is positive. Need to change that to negative, the opposite. And positive times a negative is negative. We need to change that to its opposite, which is positive. All right, let's simplify these two. Boom, boom. They go away. 0x plus 4x, that's 4x. Well, because in this case, again, the degree, which is 1, it's still the same as the 1 in the divisor. We can still do the division. We need to drop the last term in order to get that. All right, so let's see. So divide the leading term, this leading term, by this leading term again. 4x divided by x, that's a plus 4. 4 times x, that's 4x. 4 times 2, that's 8. Positive times a positive is positive, change to negative. Positive times a negative is negative, change to positive, combine. And this one gives us a 0 remainder. So in this case, that's the answer, the final answer to this division. All right, so these are a couple of examples of dividing using polynomial long division. Let's do the other case of division, the synthetic divisions. However, this method only works when we divide a polynomial when we divide it by a binomial of the form x minus c. That is, when the denominator it's only it's only a polynomial of degree 1. If, for example, if we try to do if we have a denominator with a quadratic or a cubic, then it's not going to work. All right, so let's see. Let me show you how is this going to work. So what we need to do, well, actually I'm going to do the same as example 1 in the previous, as part A in the previous page, but I'm going to do it using synthetic division. By the way, this is supposed to say synthetic. Your PDF is already fixed, by the way. So synthetic division. So what are we going to do? Number 1, keep in mind that this x squared has a leading coefficient that is invisible. And when it's invisible, this is supposed to be a 1. All right, so what are we going to do? We're going to write only the coefficients, in this case 1, 3, and 2. That is the coefficient of the squared term, the coefficient of x to the first power, and the constant term. I'm going to do this some sort of a division. And what are we going to put here? Well, number 1, this guy. What we do in this case is to set it equal to 0 and solve for x. And that's the number that is going to go here, -2. All right. What are we going to do in this case? Well, number 1, the first term, drop, multiply these two. -2 times 1 is -2, and then add these two numbers. 3 minus 2, that's 1, and then again this 1 multiply with -2, that's a -2, and then add this again. 2 minus 2, 0. The last number here indicates that remainder equals to 0. And if you look back when we did it that way, our remainder was a 0. Now, what do these numbers represent? What do these new numbers represent well. So this one used to be the coefficient of x squared. This used to be the coefficient of x to the first power, and this was only the constant term. All right, let me call it a, simply a, so we don't get confused with this other c. When we do the division, all these powers get downgraded by 1 unit. So if this used to be this used to be the coefficient of x squared, now whatever we get, this is going to be the coefficient of x. And then in this case, if this used to be the coefficient of x, 1 degree less is degree 0, basically the constant term. So in this case, our final answer will be 1x plus 1, which is simply x plus 1. All right. And in this case, notice no remainder. Remainder 0, so we're good. All right, let's do another example. Okay, for part B, let's see what we're gonna get. So list only the coefficients that it will. In this case, first be sure that no terms or no powers are missing. In this case, well, we have the cubed, the squared, the first power, and then the constant term, so we're good. So let's just write down the coefficients along with the signs. So 2, -1, -13, and 1. All right. And we need to look for the divisor number. Well, to do that, we need to set this guy, set it equal to 0, and solve the baby equation. Or simply grab the number, change the sign. Grab the number, change the sign. All right, so now let's do the division. So we drop the first term, the first coefficient, that's 2. 2 times 3, that's going to be 6. 6 minus 1, that's a 5. 5 times 3, that's 15. Put it below the next one. And then 15 minus 13, that's a 2. 2 times 3, that's 6. Put it below in the next column. And 6 plus 1 equals to 7. In this case, our last number is not a 0. This means we're going to have a remainder. Now again, this used to be the coefficient of x cubed, coefficient of x squared, coefficient of x, and the constant term. Now this is going to be the coefficient of x squared, the coefficient of x, and the constant term. All right. So our final answer will be, in this case, well, 2x squared plus 5x plus 2. But in this case, because we had a remainder, that's going to be plus 7 over the divisor x minus 3. And that's final answer for this guy. All right. Let's do one last example here. Well, so before setting up the synthetic division, the little box with the numbers, notice that, well, in this case we have 4 power, third power, second power, but the first power is missing. That means that we need to add a placeholder. Well, how is that going to look like? Well, first of all, keep in mind this is an invisible one. The first coefficient is 1, second coefficient is -2, third coefficient is -11. Well, we need the coefficient of x. In this case is 0. Be careful with it, because if you don't put this 0 as a placeholder, you may not get the correct answer. All right. So let's see. So this is going to be 34 as well. And in this case, well, so this is this x plus 2. Change, set it equal to 0. And that's the number we divide by, -2. So what do? Drop the first term, multiply these two, -2 times 1, that's -2, put it below the number in the second column. -2 minus 2, careful, that's a -4. -4 times -2, that's +8, put it below the next number. And add these two numbers. 8 minus 11, that's a -3. -3 times -2, That's positive 6. Put it below the next number. 0 plus 6 is 6. 6 times negative 2, that's a negative 12. Put it under this 34. Well, in this case, 34 minus 12, that's going to give us a 22, which in this case is not a 0, which means this is our remainder. Again, this used to be the coefficient of x to the fourth, x cubed, x to the second, x, and the constant term. Call it a. Now this is the coefficient of x cubed, 1 degree less. This is x squared, 1 degree less. This is x, 1 degree less. And 1 degree less than x is degree 0, basically the constant term. All right. Now let's see. So we need to write this quotient. In this case, the final answer to this will be x cubed, 1x cubed, we don't need to write that one, minus 4x squared, minus 3x, plus 6. And then in this case, because we had a remainder, that's a 22 over the divisor, which is x plus 2. And that's a final answer. And I think this is a good place to quit this video. See you in the next section.